Okay, I just want to talk a little bit about pendulum and SHM. It came up in that little test we did on scholarship questions. So here's my pendulum, here's a mass. Similar video on girl on a swing. We're looking at an object that's swinging like a pendulum. Now remember what I said. I said that at this stage we've got a weight force and we've got a tension force. So when it's not got any velocity in this direction, so it's at the full displacement or the full amplitude, then if we were to draw a force diagram, then the component mg cos theta would be cancelled out by the tension in the string, and we would have a net force right here, mg sine theta. Now at that point we could consider that is the force that's the restoring force, but with SHM we're only looking at the restoring force in the horizontal direction, and we're looking at the magnitude of that in terms of the distance. So we're saying that it's proportional. We're saying the force, just like a spring, is equal to or proportional, so we use proportional, to the displacement or exits. And so we're saying that force in the horizontal direction, so we could call force in the horizontal direction is proportional to x. And we could take the component of that and have a look and see if it was. But that's just one measurement, and by the time the pendulum has gone down a little bit, it's now got a little bit of velocity. So at this stage we've again got weight force, but this time we've got a bigger tension force because of that velocity needing an extra component of centripetal force. So at this stage the net vector might have passed the horizontal, and again now it's pointing up instead of down. Now at this stage what we want is again the horizontal component, or the restoring component. So when you look at a pendulum in detail, you'll find that it's really only for these small angles that that horizontal component's going to approximate this force is proportional to displacement, and therefore SHM, or pendulum and SHM, the pendulum is not doing SHM for larger angles. Important that you understand the way this vector, the net vector, changes with something swinging backwards and forwards. By the time we're in the middle, the net vector is straight up. No horizontal component, therefore no force. Definitely a net force. No force in the horizontal direction.